The Cogitating Ceviché presents Isaac Newton, a scientific giant in the digital age. Past Forward, Historical Icons in the Digital Frontier, Number 12, by Conrad Hannon. Narration by Amazon Polly. Preface. As we embark on the 12th edition of Past Forward, Historical Icons in the Digital Frontier, our journey through the corridors of history and into the realms of modern technology continues to enchant and enlighten us. Each installment of this series has not only offered a window into the past, but also illuminated how the legacies of significant historical figures resonate in today's world of scientific marvels and technological wonders. In this issue, we focus on Sir Isaac Newton, whose laws of motion and gravitation laid the cornerstone of classical physics and forever changed our understanding of the universe. Newton's profound contributions to mathematics, optics, and astronomy established frameworks that have endured through centuries of scientific advancement. As we bring Newton into the 21st century, we explore how his relentless pursuit of understanding and unparalleled genius would interact with our time's technologies and scientific challenges. From the intricate orbits of satellites that navigate by his laws to the abstract realms of quantum physics that challenge them, Newton's presence in today's scientific landscape would be grounding and transformative. His engagement with modern developments such as artificial intelligence, genetic engineering, and space exploration would undoubtedly provoke fascinating discussions, blending his 17th-century insights with the most pressing questions of our digital age. Through speculative narratives and imagined interactions, this series aims to celebrate the enduring impact of Newton's work while examining the ethical and philosophical questions that arise as we push the boundaries of what science can achieve. As Newton himself might have marveled at the technologies that his principles have made possible, we too marvel at the persistent influence of his ideas, which continue to inspire and challenge scientists, educators, and thinkers across the globe. Join us as we continue this intellectual odyssey, tracing the threads of history into the fabric of modern science and rediscovering the timeless relevance of Isaac Newton's legacy in shaping the future of human knowledge. Onward, as we delve deeper into the past to uncover the insights that will guide us forward in the ever-evolving landscape of the digital frontier. Conrad T. Hannon. Introduction: A scientific giant in the digital age. Imagine the scene. Sir Isaac Newton, a colossus of science, finds himself suddenly transported from the 17th century to the bustling heart of the 21st century. His eyes widen as he steps into a world pulsating with digital screens, rocket launches, and autonomous vehicles, all phenomena that, in one way or another, trace their lineage back to his laws of motion and universal gravitation. As Newton wanders through a modern physics laboratory, he encounters devices and experiments that seem like magic but are deeply rooted in the principles he once penned by candlelight. His seminal work in calculus, optics, and mechanics now supports innovations he could scarcely have imagined. The calculus that once quantified the falling of an apple now calculates the trajectories of space probes to distant planets. The optics that explain the spectrum of light now power lasers and fiber optic communication spanning the globe. Newton's initial astonishment gives way to a profound curiosity as he interacts with contemporary scientists and engineers. He marvels at the precision with which modern technology can manipulate light, matter, and information, reflecting on the fundamental truths he uncovered that continue to guide scientific inquiry and technological advancement. Each discovery and explanation offers him a glimpse of how deeply his work has permeated the fabric of modern society, driving forward an endless frontier of innovation. This journey through the digital age reconfirms the universality of Newton's discoveries and revitalizes the awe and wonder at the core of scientific pursuit. His presence in today's world highlights centuries-long dialogue about the persistent nature of scientific truth and the unending quest to understand the universe at both the grandest and most minute scales. Modern physics and Newton's legacy. As Isaac Newton steps further into the exploration of the 21st century, he encounters the enigmatic realms of quantum mechanics and relativity, fields that challenge and extend the classical mechanics he pioneered. These new domains of physics, which would appear almost mystical to him at first, represent a stark departure from the absolute and deterministic universe he understood. Confronted with quantum mechanics, Newton might initially grapple with its probabilistic nature and the peculiar behavior of particles that exist in states of superposition. The principles that govern the microscopic world would seem to contradict the predictable laws he formulated for macroscopic objects. Yet, his profound analytical acumen and his foundational work in calculus might soon lead him to appreciate the mathematical elegance and experimental validation underpinning quantum theory. Engaging with the theory of relativity, Newton would find that his laws of motion are but special cases within a broader framework defined by Einstein. The concept of spacetime curvature and the relative nature of time and space might challenge his notions of absolute space and time, but the logical continuity from classical to modern physics would likely fascinate him. Newton could find himself in deep theoretical discussions with modern physicists, using contemporary mathematical tools like tensor calculus, a technique beyond his time but one that he could appreciate for its ability to describe the fabric of the universe. Newton's potential contributions to these discussions would be invaluable. With his keen insight into the mechanics of motion and gravitational forces, he might offer novel perspectives or even pose critical questions that could lead to new experiments or theories. His ability to abstract and generalize from empirical data would make him a formidable thinker even in today's advanced scientific landscape. Through these interactions, Newton would learn of the universe's more mysterious layers and contribute to its understanding, bridging his 17th-century insights with 21st-century physics. This blend of Newton's legacy with modern scientific challenges underscores scientific knowledge's dynamic and evolving nature, where each generation builds upon the foundations laid by those who came before. Technology inspired by Newtonian physics. As Isaac Newton traverses the technological landscape of the 21st century, he would encounter a myriad of engineering marvels directly inspired by the principles he formulated centuries ago. Newton's laws of motion and his theory of universal gravitation are fundamental to the designs and functions of many modern technologies, from the orbits of satellites to the stability of towering structures. Newton might first marvel at the aerospace industry, where his laws underpin everything from the flight dynamics of airplanes to the trajectories of spacecraft venturing beyond Earth's atmosphere. For instance, the sight of a rocket launch would directly demonstrate his third law: for every action, there is an equal and opposite reaction. Observing how engineers use his principles to calculate escape velocities and orbital paths would likely astonish him, providing a tangible link between his theoretical work and its practical applications. Newton would be particularly fascinated by satellite technology, GPS systems, as it would be particularly fascinating. These systems rely on precise calculations of time and distance, integrating the effects of gravity and the speed of light, concepts that Newton himself helped to explore. He would be intrigued by how his laws facilitate not just the positioning of satellites in stable orbits, but also the synchronization necessary for accurate global positioning, impacting everything from navigation on smartphones to timing in financial transactions. Additionally, Newton's influence extends to the design of high-speed trains and advanced architectural structures. Modern civil engineering incorporates Newtonian physics to ensure the stability and safety of buildings and bridges, calculating forces and stresses that materials must withstand. High-speed trains also exemplify Newtonian mechanics, utilizing his laws to optimize speed and minimize friction. Newton's exploration of these technologies would deepen his understanding of how his scientific legacy continues to shape the world and spark his imagination about future innovations. His foundational work, once confined to paper and the intellectual salons of the Enlightenment, now drives the engines of global development, demonstrating the enduring power of scientific inquiry to inspire solutions to complex challenges in engineering and beyond. Educational technology and Newton's methods. Isaac Newton, a consummate educator and communicator of scientific ideas during his tenure at the University of Cambridge, would likely embrace the transformative potential of modern educational technology with enthusiasm. Confronted with digital platforms that offer unprecedented access to information and interactive learning tools, Newton would see a golden opportunity to further his lifelong mission of disseminating knowledge and fostering scientific inquiry. Newton might be particularly captivated by the capabilities of online educational platforms that allow for creating and disseminating massive open online courses, MOOCs. These platforms could enable him to reach an audience far beyond the hallowed halls of academia, offering courses on calculus, optics, and the laws of motion to students worldwide. Once limited to those who could hear them in person, his lectures could now be accessed by anyone with an internet connection, complete with subtitles and translations to bridge linguistic barriers. Moreover, Newton's keen interest in demonstrating scientific principles through experiments would find a perfect match in developing interactive simulations in virtual laboratories. These tools would allow students to visually and interactively explore the principles of motion and gravity, conducting experiments in virtual environments that eliminate the constraints of physical materials and safety concerns. For instance, students could manipulate variables to see real-time changes in projectile motion or observe the effects of different gravitational forces on objects, deepening their understanding of Newtonian physics through hands-on learning. Newton would likely collaborate with developers and educational technologists to create simulations that teach scientific concepts and encourage critical thinking and experimentation. He could guide the design of virtual labs that allow students to test hypotheses and observe outcomes, mirroring the empirical approach he championed. The potential to use modern technology to advance education and make learning more accessible and engaging would resonate deeply with Newton. His commitment to education and methodological rigor would make him a pioneer again, this time in the digital frontier of learning. Through these platforms, Newton could continue his legacy of inspiring and educating future generations, demonstrating that the core principles of physics are foundational to the universe and humanity's continual education and empowerment. Ethical considerations in science. Isaac Newton, who navigated both the accolades and controversies of scientific discovery in his time, would find the ethical debates surrounding modern science and technology both familiar and pressing. In an era when science was increasingly entwined with philosophy, theology, and the machinery of society, Newton understood the profound implications of scientific advancements. Transplanted into today's context, he would likely approach the ethical dimensions of contemporary science with a thoughtful and measured perspective. Newton would be particularly intrigued by the ethical challenges of cutting-edge fields like artificial intelligence and genetic engineering. Given his deep philosophical inquiries and religious beliefs, he would appreciate the complexity of debates surrounding the creation and use of autonomous AI systems, which raise questions about free will, privacy, and the potential for societal disruption. Newton might engage in discussions regarding the moral obligations of AI developers to ensure that these technologies enhance human welfare without infringing on human dignity or autonomy. In genetic engineering, Newton would encounter a scientific frontier that directly manipulates the building blocks of life, a concept that would resonate with his alchemical pursuits and his quest to understand nature at its most fundamental level. He would likely be captivated by the potential of genetic technologies to cure diseases and improve human health, but also cautious of their potential to alter human genetics in unpredictable or ethically questionable ways. Newton's approach to these discussions would be grounded in a principled framework that considers the scientific and technical aspects, societal impacts, and moral implications. He would advocate for a balanced perspective that respects the power of scientific knowledge while recognizing the responsibilities that come with it. Discussions with contemporary scientists and ethicists would benefit from his historical and philosophical insights, bridging ideas from his time with the challenges of the modern era. Overall, Newton's engagement with today's ethical considerations in science would emphasize the importance of integrity, responsibility, and foresight, principles he held in high regard throughout his scientific endeavors. His perspective would remind the scientific community of the need to push the boundaries of what is possible and carefully consider the broader impacts of these advancements on society and future generations. Conclusion: Newton's enduring influence. Isaac Newton's influence permeates every facet of modern science and technology, a testament to the enduring power of his intellectual legacy. Newton's principles continue to underpin a vast array of scientific disciplines and technological innovations, from the orbits of satellites to the smallest particles studied in quantum mechanics. His work, which laid the groundwork for classical mechanics and provided the tools for calculus, remains foundational in theoretical explorations and practical applications. In today's context, Newton's contributions would be celebrated for their pivotal role in advancing human understanding of the natural world. His laws of motion and universal gravitation have enabled remarkable feats in engineering and space exploration. The mathematical methods he pioneered are still employed by scientists and engineers to model complex systems across numerous domains. However, Newton's work would also be critiqued in light of modern scientific developments that expand upon or challenge his theories. The advent of quantum mechanics and general relativity has reshaped our understanding of the universe at the largest and smallest scales, offering perspectives Newton could never have envisioned. Engaging with these contemporary theories, Newton would likely be both a student and a contributor, eager to learn about these new realms while offering insights grounded in his scientific methods. Moreover, Newton's role as a public figure, who was both revered and controversial, would resonate with today's scientists navigating the public responsibilities of their work. His experience dealing with the scientific community and the public's reception of his ideas would provide valuable lessons for modern scientists on communicating complex topics in an accessible manner and handling scientific debates. Ultimately, Newton's legacy in the 21st century would be one of inspiration and continued relevance. His curiosity, rigor, and creativity in approaching scientific problems encourage ongoing innovation and caution in scientific practice. By imagining Newton's interaction with modern science and technology, we gain a deeper appreciation for his contributions and insights into how the foundational principles of science continue to inform and shape our world. Newton's story is a vivid reminder that the quest for knowledge is an ever-evolving journey, where the past and present dialogue illuminate the path forward. Thank you for stopping by today. Until next time, stay gruntled.